All right, so we're not going to multiply this thing back out. That's what two people have said so far. No, that's undoing the factoring that happened. We can't do that. That makes us work backwards. We don't want to do that. If two things are multiplied together and they equal 0, what do at least one of them have to be? At least one of them's got to be 0. These have variables in each one, so it's entirely possible that both of them are 0, right? Because 0 times 0 is also 0. So the zero product property is what that's called. So the zero product property tells us that if two things are multiplied together and they equal 0, then at least one of them is 0. It could be both of them. Since there's a variable in each of them, we're going to assume that it could be both of them. So we set each factor, once it's factored, set each individual factor equal to 0 and solve those. These are one-steppers. They're really easy to do. Subtract 3, x would be -3. Add 10, x would be 10. Y'all remember doing that in Algebra 1? Yeah. You should. It was not long ago. Long time ago was something that happened when you're 2 years old. Last year is not long ago. 2 years ago is not long ago. Shouldn't get dumped out. You're responsible to remember it. All right. So here's a problem. We need to follow the rules here. Number one rule is that if we're solving an equation by factoring, it needs to be equal to what? 0. Is this one equal to 0? Yes. So that means we can start our rules of factoring. Is it in descending order? Yes. So the next thing I look for is a greatest common factor, which is 5x. So we pull a 5x out to the front. What's left in the parentheses? 2x plus 1. Look at the parentheses. Can I factor that any further? No, it doesn't have a minus sign in the middle. It doesn't even have a squared on the x. So what do I do with each of those things? Set them each equal to 0. Divide by 5. 0 divided by anything is 0. So 0 is one of our answers. This one we subtract 1. And then divide by 2. -1/2. Do not change that into -0.5. Getting to the point now, I will count it wrong. Okay? You're not following my directions. Don't change it to decimals. I don't care what photomath does. All right. 5x squared minus 17x is equal to -6. What's wrong with this? Not equal to 0, so I can't solve it by factoring yet. So I need to do what to get it equal to 0? Adding 6 to the other side would be the shortest way to get there. Technically, it wouldn't be wrong to move the 5x squared and the 17x, but why would you do two things when you can do one? So 5x squared minus 17x plus 6. So I rewrote that in descending order just to make sure it was there. And now I can start doing my factoring rules. X method has got 3 terms. So what goes on the top of the x? 5 times 6 is 30. So that's the number up top. So always front number times the back there when it's got 3 terms. And then what goes on the bottom? -17. So I need 2 numbers that multiply to be positive 30 and add to be -17. -15, -2. Doesn't matter what order those go in. I'm going to put the 15 up there close to the 5x, and then the minus 2x close to the 6, because it makes the GCS a little easier. Okay. Now, once I've replaced the 17 with the 15 and the 2, I do what? Grouping. First 2 together. What's GCF of the first 2? 5x. What's left in parentheses? X minus 3. Second group. pull out a -2, and it makes it x minus 3 in there. Now what? Five x minus 2, x minus 3. This is the factored form of that. So the factored form looks like that. Now what do I do with each factor? Set them equal to 0. So 5x minus 2 equals 0. X minus 3 equals 0. Solve those. Should be 2/5 and 3. And I'm absolutely okay with you solving those at the end there in your head. That's fine. I would like to see your factored form there. I mean, I don't. Some of you might be able to factor in your head. I don't know any of you that could, but there might be some of you that can. But the solving those 2-step and 1-step equations, you should be able to do. Let's try this one. X squared plus 12 is equal to -8x. Okay, so to get it equal to 0, adding 8x would, getting rid of that would work. X squared plus 8x plus 12. And do the x method. What's on the top of the x? 12, 8. What does that? 6 and 2. Can I take a shortcut on this one? Yeah, because there's a 1 in front of x squared. That allows me to go x plus 6, x plus 2. That's my factored form. And then what do I do with each of those? Set them equal to 0. And then we know the sign changes. Those are easy to do. 1-steppers. So pretty easy so far, right? It doesn't get much harder. Let's do one that's a little bit more difficult because we're smart and we can do it. 3x squared plus 10x minus 300 is equal to 15 minus 2x squared. This one got a lot more stuff in it. Makes it a little bit tougher to do. Okay, combining like terms, what do you mean?
Adding the 2x squared to the 3x.
Okay, so adding the 2x squared to the 3x squared gets rid of that piece. What else?
15.
How do I move it, the 15 over? Subtract it because it's a positive 15. So add 2x squared. And I'm just going to move the 15 the same in one step there. Not going to write 2 separate steps for that. Just put it all together. These cancel out. There's my equals 0. Excuse me. And then so we got 5x squared plus 10x minus 315 is equal to 0. So 5 is the GCF of all of those. So that's nice because then I got the shortcut coming up. 5 goes into 315 63 times. And then X method on the parentheses, -63 had to be 2. -7's got to be 9 and -7. That had to be a positive 2. And I can take the shortcut on that, so that's x plus 9 and x minus 7. And what's that 5 in the front? What's the deal with it? Do you? That doesn't make any sense. Does 5 ever equal 0? No. No. Don't distribute it because that's going backwards from what we've done, right? Divide it to both sides because it doesn't have a variable on it. It's just a regular number. If you had an equation that just had 5x is equal to 45, you'd solve it by dividing by 5, right? This one's the same idea. You just have a 5 in front of some factors. So if we divide both sides by 5, it gets rid of it. If it doesn't have a variable, then you basically just drop it. That's what happens. If it has a variable, whole different game. Okay, you got to use it. But because it doesn't have a variable, it gets dropped off. And then we set those equal to 0. -9 and +7 should be our solutions, zeros, roots, x-intercepts. All of those things mean the same thing as where an equation equals 0. Questions about that one? We're on here. That's 5. Let's do number 6. Aaron, can you stop? So you got to talk about it? 3x squared minus 20x plus 6 is equal to -2x squared minus 3x. Okay, so which direction do you want to go here, though? Doesn't matter. Good question.
It doesn't. Well, I would add the 2x.
Okay, she says I will add the 2x. Fine. Okay, that makes it factoring a lot easier when there's not a negative sign in the front, right? Because then we don't have to deal with an extra negative in the problem. So that's a great strategy. So anytime that you can get your first term to be positive, it's going to make things easier on you. Okay, so adding 2x squared over here, that's a great idea. I think that's the best case. Does it matter? No. Mathematically, it's the same problem no matter which direction you move things. Okay, but for ease of work, does it matter if you use a hand screwdriver or a drill gun? No, both of them do the same thing, but which one's the easiest to use? You know, so you want to try to do that, use the easiest method. So I'm going to move the 3x at the same time. So I'm moving everything to the left side there to get 5x squared minus 17x plus 6 is equal to 0. Well, that looks familiar. So if I do the x, that's 30 and -17. And -15 and -2 does that. Oh, it's a similar problem to what we've done before. So similar that it's the same. But it didn't start out the same. Group it. 5x, x minus 3. Group -2, x minus 3. And there we have the factors 5x minus 2, x minus 3. Set those equal to 0. To this. And 3. But again, having a positive in front of your leading term is always easier to work. One more. Again, remember we're solving by factoring, not by other methods. You may know some other methods, or remember from what you said earlier. I guess you don't remember anything from Algebra 1, so I don't have to worry about you doing it a different way. You don't know anything about Algebra 1. So 16x squared is equal to 49. So that, if we follow the rules for solving by factoring, what should we do first? Subtracting the 49 would be a good move because that leaves the descending order with the positive number in the front. So 16x squared minus 49 that's got two terms on it, right? Minus sign in the middle, so that makes us think this is a difference of squares. So that means I should be able to rewrite it like this, if it will factor. What squared gets me 16? 4, and then because it's got x squared, it needs an x as well. What squared gets me 49? 7. Okay, so since I could rewrite it that way, that means my factors are what? Yeah, 4x minus 7, 4x plus 7. Set those equal to 0. So solve those, be 7 over 4 and negative 7 over 4. Not bad, right? Pretty easy. Okay, let's do one more and we're done. This one's a little different than the rest of them. Let's say we had f of x is equal to x squared minus 7x plus 12. And they said find the zeros. So how do we find the zeros of that function? So what do we got to set it equal to first? 0. So finding the zeros of the function means find where the thing is equal to 0. So you just take whatever f of x is, and you're setting that problem equal to 0. So anytime you come across a polynomial or any kind of equation that says find the zeros, or maybe it says find the roots, that's a synonym for zeros, or find the x-intercepts. We did that with linear ones. We find the x-intercepts by setting the problem equal to 0, or setting y equals 0. That's what we're doing here. Zeros, roots, x-intercepts, those are all the same thing. They mean the same thing. So then you do the x method. 12 and negative 7 be negative 3 and negative 4, right? So x minus 3, x minus 4. And set each of those equal to 0. And you get those numbers. So what that means is this one, if you graph that, which is where we're headed after we do benchmark on Thursday, set into graphing quadratics. We graph that, it's going to cross the x-axis at 3 and 4. That's really what we're finding. We're using algebra to find that stuff right now, but that's going to help us when we go to graphing. So that's what we're really finding out of this. So that idea is what's going on here. Pretty easy practice for today. Quiz tomorrow will have just factoring on there, and then solving by factoring on there. That's the only things that'll be on it. So it's just 2 things that are on that, and that'll be your last quiz grade of the 9 weeks. When you get this, go ahead and mark out number 19 and 20. Probably be 10 or 11. Well, we will be moving forward. Well, call break is a week. Go ahead and mark out number 19 to 20. We didn't talk about imaginary numbers or anything yet, so just mark those out. And so you're just doing 1 through 18 there. Solving them. Okay. No, because it's already, yeah, that's fine. It's already back before you. I was going to take it. Wait. Okay.